Okay, you're given the graph of y equals 2x cubed, which is this graph right here. The line y equals 0, which is the x-axis. And the line x equals 3, which is this vertical green line. This region right in here is revolved around the line x equals 8. You're told to use the disk method to find the volume. By the way up here, there's a point where these two graphs intersect at 3, 54. If you use the shell method, which has typical shells perpendicular to the axis of revolution, the problem's pretty easy. We have 2 pi times the definite integral from 0 to 3 of the height of the shell, of a typical shell, which is 2x cubed, times the average radius, which is the distance from the axis of revolution to the center of the shell. And this distance will be x. So 8 take away x will be the length of that. And that's what this is right here, the average radius. You can see that gives you 1425 point blah, blah, blah. Here's the exact answer. Now, using the disk method gets quite a bit more painful. Okay, we want our typical disks to be, I think I said perpendicular for the shell method. It's actually parallel to the axis of revolution. Okay, but for the disk method, we want the typical disks to be perpendicular to the axis of revolution, and that's where we're using outer radius squared minus inner radius squared. And to do that, we have to solve this equation for x in terms of y. So x cubed equals y over 2, or 1/2 y. So x equals 1/2 y to the 1/3 power. So the outer radius is this distance right here, which is 8 take away whatever this distance is, a horizontal distance. And that distance for every y is 1/2 of y, quantity to the 1/3 power. That's what this is right here. So there's the outer radius squared minus the inner radius is constant because we're going from 8 to 5, or 8 to 3. So this is actually 5 squared, or 25. Calculating it this way becomes very painful. And I'm going to get you started on board 2 to find the antiderivative of this. We first want to square this binomial and then subtract 25. So to square a binomial, square the first term, double the product of the two terms, then plus square the second term. And then we have this minus 25. So here's what we're doing right here. Finding the antiderivative of that function. So 39y minus 16 times 3/4 times 1/2 to the 1/3 times y to the 4/3. In other words, I raised this exponent by 1 and multiplied by the reciprocal of the new exponent. And we do a similar thing over here. Raise this exponent by 1 gives us 5/3. Multiply by the reciprocal of the new exponent. And there's what we're evaluating from 0 to 54. Obviously, if we put zeros in for y, we'll just get 0. Now, I'm not going to do the whole thing here, but I want to just give you an idea of how to evaluate this second term when you put 54 in for y. 1/2 to the 1/3, if you rationalize that, you get the cube root of 4 over 2. And I showed the steps for doing that. And 54 to the 4/3 is the 4th power of 54, the cube root of 54. The cube root of 54 in simplest radical form is 3 cube root of 2. Raise that to the fourth power, you get 81 times 2, because the cube root of 2 times the cube root of 2 times the cube root of 2 is 2. And then we have one factor of cube root of 2. It's 162 cube root of 2. And when you multiply these two together, you get 162 divided by 2. That's this right here. The key is the cube root of 4 times the cube root of 2 is the cube root of 8, which is just a 2. So believe it or not, this entire expression with all these fractional exponents simplifies to a number like that. The radical disappears. And that's what's going to happen over here. You have to find an expression for 1/2 to the 2/3, which is the same as 1/4 to the 1/3. I'm not going to complete that for you, but you do a similar thing to what I did over here for the second term. You'll get over 5. And you'll have to convert this to fifths, combine, multiply by pi, and you'll get that exact answer that we showed right here. A lot simpler doing the shell method. Okay, there you go. Hope that gave you some idea of what to do. If you have any questions, post a comment.